rise to the templates. Under the idea that it's templates that were created close together are more likely to merge than one that, say, appeared in paragraph 1 and another in paragraph 5. The content, how are these well-populated templates? Do they overlap in content? If they do, then that's probably a good sign that they're reliable and should merge, and not if not. So I dumped a corpus of every merge that the system tried from when applied to the training text. Try to coded up a classification tree in the style of Browning et al. And a max entropy modeling technique, the IBM technique that you're, I'm sure, very familiar with. Tried a threefold experiment and found that according to my annotations, the learned mergers were only making about a quarter of the mistakes that the original merger was making. So that sounds great. It looks like I'm actually was a little surprised. We found some structure in this data. So I went ahead and trained on all the training data and then changed the merging algorithm in fastest to be directed by these new learned classifiers. And sure enough, when you run a system end-to-end, you get no performance or even a little decrement in performance. And this was even on the 100 development texts that gave rise to the merges that I annotated to begin with, right? This is very strange. So for starters, it seemed to show that what I thought merging was doing for the system and what everybody else at SRI thought merging was doing wasn't actually what wasn't what it was doing in helping us improve our score. And you can see some cases where this might be true. So let's say there are cases where on a text we incorrectly extract templates for 2 events. They're both wrong. And if we output those events, we would get a bad score. But then the merger might happily come along and incorrectly merge these 2 incorrect events, giving us 1 event that's going to negatively affect our performance. And it's actually an improvement to do something like that. In any case, at this point, I thought, okay, well, if we're interested in improving our F-score, given this experience we've had, we should have F-score being driving the learning process. So I tried something called indirectly supervised learning. So the idea is you have a little parameterized model embedded in the system, but you're trying to train that model from end-to-end system results. Now, I'd like to say that I did something really clever here, but it's very hard to figure out in a system like Fastest how to